ladies and gentlemen, we're going to take a look at the third lesson in Chapter 8, and we're going to take a look at the area of squares and rectangles. And so I'm guessing at this point, there are a number of you who are ready to fast forward because you know how to find the area of squares and rectangles, and you do. What we want to make sure is that we understand how to not only find area, but then to take that and find dimensions, and then how to find area of polygons, meaning something that doesn't fit in the category of a square or a rectangle, but how can we use squares or rectangles to help us? So when we look at area, it's the amount of surface covered by a figure. So the floor is an example. We talk about the square. We talk about the area of a floor. The surface that is covered by the floor. A wall. We talk about the area of the wall is the surface that it covers. Okay, and so these are only, we talk about area with two-dimensional figures. And so squares and rectangles work out well because they have two dimensions, their length and their width. So let's take a look at this. The area of a square. The area of the square, or of a square, is the square of the length of its side. Because a square has 4 equal sides, they're all the same measure. So if this side over here on the right is S, that means your bottom is S, your left side is S, and your top is S. So how do we write that? Well, we're going to square the side measurement. We don't know the value for it, we just know that it's S, so it's going to be S squared. So now let's find the area of a square. So we're going to use the formula, and we're going to substitute 7 for S because that's our side length. So area is S squared, and we're going to take 7 squared, and that's 49. If we look, we have feet as our unit, so this will be 49 feet squared. You're doing 7 feet times 7 feet, and so feet times feet is feet squared. And so the way we can look at our answer is that the area of the square is 49 square feet. So we can write it out in words, square feet, or we can use our exponent notation and write it as feet squared. But your answers are going to have some sort of a label. So let's say we know that the area of a square is 49 square feet. What calculations can you perform to find the length of the side of the square? So you squared something, the formula, area equals side squared. The question we want to figure out is how do we undo squaring? So I want you guys to think about that. We'll talk about this a little bit more in class, but I want you guys to think about how would you undo squaring. And what I mean by that is we undo adding with subtracting, and vice versa. We undo subtracting with adding. We undo multiplying with division, and then vice versa. We undo division with multiplication. So how do we undo squaring? We will do this in class. We'll finish that up. All right, so now what we want to do is talk about the area of a rectangle. So the area of a rectangle is the product, that means we're multiplying, its base and height. The other way we're used to thinking of that is length and width. Many of you, if I were to just ask you that question, would say length and width. So area equals B times H, base times height. So example 2 is finding the area of a rectangle. So we want to find the area of the rectangle. We're going to substitute 5 for the base and 3 for the height. So we have 5 times 3, which is 15. We need to think about our labels. These are centimeters. So it's going to be centimeters squared because we had 5 centimeters times 3 centimeters. And so we have centimeters squared. we can write it out as the area of the rectangle is 15 square centimeters. So one of these two labels, either square centimeters or centimeter squares, squared, shows up when we're looking at rectangles. So like I said at this point, this is probably a lot of review. I feel like we used area last year in algebra. I know you've seen it in elementary school because I've worked at it at home with homework for my kids. So right now we should be very comfortable. All right, so our follow-up. Find the area of the figure at the right using the formula for the area of a square. So the area of a square is s squared, so that's 4 squared, which is 16, and we're going to have inches squared. So now we want to find the formula, find the area of the figure above, so that same figure that we used, using the formula for the area of a rectangle. So we need to do base times height. So the base is 4, this is our base. We're going to multiply by our height, this is our height. And so once again we get 16 inches squared. So the question I want you to answer for me is this: why can you use either square or rectangle formula to find area? So I want you guys to do now, and we will check in class. All right, so now what we're going to do is start finding dimensions. They're asking us to find the height of the rectangle here. So we know it has an area of 54 inches. It's a little difficult to see on mine. Hopefully it's a little bit easier to see in your book. But we have an area of 54 square inches. Find the height. The formula is area equals base times height. The area is 54, so we're substituting what we know. So 54 for the area. We're going to substitute 9 for B. To undo this multiplication, we actually just talked about that. We're going to divide. And we're going to divide each side by 9. So when we divide by 9, we get 6. We need to have labels. So the height of the rectangle is 6 inches. You are going to show work. I want to see what you're doing. So simply filling out this formula here and showing me that you are dividing by 9 on each side to get the 6 is what we'll want to see. So you guys have a checkpoint. I'm going to leave these for you to do. These are all finding area. So you're finding the area of each of these 3 figures. We have a square and then 2 rectangles. And then here we know the rectangle has an area of 52 square meters. We want to find the base. So you have area equals base times height. Plug in what you know and then solve for the base. So you guys are going to do now, so pause the video and then we will check in class. Alright, so then where we go to is we're going to take a look at these, what they call complex polygons. And they're going to have us divide it into rectangles. And so they've kind of already done that. They divided it into rectangle A and rectangle B. So when we look at rectangle A, it has a base of 5 units. Even though it's labeled here at the top, it's still the base. And because rectangle B is 2 inches taller, they give us this dimension here. We know that the height of A is 7 minus 2, which is 5 units. So we now have the height of A, and we have the base of A. So we want to do the same thing for B. If I look at B, the height is rather easy to see here. So I know the height is 7 units. Notice because there's no measurements given, we just label it with units. And then the base of B is the total 9 minus the base of A. So we're going to have to do 9, but we have to cut off these 5 units. If there's 5 units here, there's 5 units here. So 9 minus 5 gives us a length of 4. Or a base of 4. So we have dimensions now for B. We have dimensions for A. So how do we use those? We're going to use those to find the area of a complex polygon. So if we take a look at this, we need to divide it up. So we're going to divide it into F and then we're going to do G and H. So that's how the book wants us to divide these up and see what we can do there. We can see that F has a height of 3 and a base of 4. So base times height is 12 square centimeters. If I look at G, well, I've got to do a little calculating here. When I look at G is not all of this, I guess if we look at G up here, we have 7, but we know from here to here is 4. So if I do 7 take away 4, that gives me 3. I need to figure out this height here, and so the whole side is 9, but I know the height of H is 2, so I have to do 9 minus 2, and that gives me 7. So I have 7 times 3, which is 21. And now if we look at H, because I brought that 2 over, I have 2 times 5, and that gives me 10. So we're going to take and add all of those up. 12 centimeters squared plus 21 centimeters squared plus 10 centimeters squared is going to equal 43 centimeters squared, or 43 square centimeters. For the follow-up, they want us to take that same example and find another way to divide that up. So we are going to make this an in-class project at your table. So save this follow-up for in-class. For number 5 for checkpoint, and for number 6, they've kind of already divided your rectangles. So they want to give you an idea of how to do those. If I look, this rectangle is 3 by 7. So for this top one, if I call that A is equal to 3 times 7, which is 21 inches squared. I need to now look at B. Well, I know that this whole side is 6. I can carry this 3 over. 6 minus 3 leaves me with 3 down here. I need to find this, I know this length is 7. I know that from left to right is 4. So when we think about having a total of 7 all the way across, and this small section goes over 4, this leaves me with 3 inches. So for this B, we actually have a square of 3 times 3, which is 9 inches squared. Guys, these problems are usually a little bit easier for those of us who are good with our spatial reasoning. Those of you who struggle seeing the connections there, we'll need to work together with these in class. But start getting used to carrying these measurements over. But now we're going to add those together, and we get 30 inches squared. So for number 6, they give you a rectangle there. They give us a little rectangle here that we can work on, and then they give us a big rectangle here. So see what you guys can do with those, figure those out, and we will see you guys tomorrow.